Okay, just wanted to talk here about Bernoulli Trials. But before we figure out how to use them, the procedure, the formula, it's really important because obviously it may mention Bernoulli Trials in the question. A lot of times they'll just say, listen, figure out the probability of this, and you have to recognize in each case when it's appropriate to apply or to use a Bernoulli trial. So basically that's what we're looking at now. So basically just in terms of a trial, what's a trial mean? Well, in probability it basically means one instance of an event. So that might be one throw of a dice or one flick of a coin or one penalty kick, that type of thing. So these are the conditions. There are 4 conditions and it's important you basically have to know these. They must all be met before using Bernoulli trials. Okay, so if any one of these aren't met, then you find an alternative method. There's any amount of different methods that we've looked at already, and there's other ones. So first thing is there's a finite number of trials. So it mentions somewhere in the problem that in 10 penalty kicks, what's the likelihood of this happening? In 100 years, what's the chances? That type of thing. So it has to be specific and it will mention that number in the question. Okay, so a couple of examples there that we give. Will you ever win the lotto? Well, there's no finite number of trials. Well, how many times are you going to play the lotto? You haven't told us that. What is the likelihood of Paul Pogba scoring his next 5 penalties? That's a finite number of trials, 5. What's the chance of him scoring all of his next 5 penalties? So out of 5 penalties, he's going to be successful in 5. So that would be suitable for Bernoulli. There are only 2 outcomes, success and failure. So again, the Paul Pogba penalty question meets this condition as he either scores it or misses. It doesn't matter whether the goalie saves it, it hits off the post and goes wide, he puts it blazes over the bar, whatever. Ultimately, it either goes in the net or it doesn't. It doesn't matter who, why, where, when. Success and failure is very clear cut. Working out who will win an All-Ireland Football Championship is not suitable here as there are more than 2 possible outcomes. The third condition, trials are independent. So the Paul Pogba penalty question passes this condition also, as in theory each penalty is independent of each other. So, but a lot of these questions, I suppose, don't take into account mental pressure, if it was a World Cup final or that type of thing. Drawing a random card would not be independent, as the likelihood of drawing an ace would change depending on whether one has been drawn already. So if you draw a card from a pack and don't replace it, well then there's one less card to choose from the next time you go and pull out a card. So the probability is changing on the chance of you pulling an ace. The probability changes for every card that comes out of the pack. The last condition then is the probability of success is the same for each trial. So the lotto event we discussed in expected value previously would not pass this condition, as well as with each ball removed or drawn and not replaced, the probability of drawing each ball changes, similar to what I said there about an ace and cards. Paul Pogba's penalty question would pass this condition as again in theory the probability of success and failure is the same for each penalty. Okay, so once you run your problem through those 4 conditions, if you're happy that it meets all those 4 conditions, then you use a Bernoulli. If it doesn't, well then you need to look at what other strategies do you have available, tree diagrams, NPR, NCR, that type of thing. So we'll just quickly go through some problems here, and we can just, as you can see, I have answers already. So the probability of getting exactly 2 tails when a fair coin is flipped 5 times. So a finite number of trials, yes. Only 2 outcomes, either a head or a tail. Trials are independent, yes. The probability is going to be the same throughout. And the probability of success is the same for each trial. So basically the probability of success is 0.5 or a half. So that absolutely is meets all 4 criteria. Second one, a coin is flipped until 4 heads turn up. So no specified number of trials, so we have a problem there. Third one, again, no, there are more than 2 possible outcomes, win, loss or draw. In a family of 7 children, yes, that's fine. 5 part 1, yes, the probability of success is the same for each trial. Part 2, no, probability won't be the same, again because we're not replacing the card. The total on the bottom for your probability is going to be reduced. and all the other ones do meet the 4 conditions, so they're okay for Bernoulli. So again, if it doesn't meet any of these 4 criteria, you can still work out the probability, you just can't use Bernoulli. Okay. Once you've confirmed that the problem meets all 4 conditions, then you can proceed with using the formula. This formula can also be called Bernoulli distribution formula because it's based on the binomial distribution formula, basically. Our formula here appears on page 33 of your maths tables, and N stands for the number of trials carried out, R stands for the number of successes that you want. So what's the probability of in 5 penalties him scoring 4? So that'd be R would be 4, N would be 5. P then is the actual probability as a fraction or decimal or whatever of success. Okay. R then is whatever number you have in for R. So, and then Q is the probability of failure, and obviously P plus Q must add up to 1 because it's either going to be a success or failure. It has to be one of those two things. And then you have to the power of N minus R. So for example, what's the probability of Paul Pogba scoring out of 5 penalties scoring 4? So N would be 5, R is 4, then N minus R would be 5 minus 4, which is 1. Okay, so we're just going to go through an example here. We have an insurance firm calculates that a client has a 1 in 20 chance of having 1 or more accidents. If the client is insured for 10 consecutive years, find the probability that he will have no accidents. Okay, so basically what we're doing is we're finding, we'll just write out, a couple of things. So N is 10. That's not going to change for part 1 or part 2. N is 10. P is the probability of him having an accident. I'm not saying that's a success, but it doesn't, P is 1 over 20. Q is 19 out of 20, because 1 minus 1 over 20 is 19 over 20. And then for part 1, what's the probability of him having no accident? So probability of 0. Okay, so when we say P is 0, what we're actually doing is saying, well, R is 0. Okay, so we have our formula. N is 10, and what is the chances of out of those 10 years that he has no accidents? All right, so we're just going to put in P. Again, we're just following the formula from above. R is 0, and then we have 19 out of 20 to the power of 10. Okay, when you put that into your calculator, you'll get 0.5987. Okay. What was so that's the answer to part 2 or part 1. He will have part 2. He will have an accident. What's the probability that he will have an accident in more than 1 year? Okay, so more than 1 year basically means 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Okay, it's not practical to work out. You would have to work out the probability P2, P3, P4, P5 and go all the way up through it. That's not practical. It's a lot easier for you to find out the probability of having either 1 or 0 and subtracting that from 1, and that'll give you the rest. Okay, so we've already worked out P0. So basically what we're saying is the probability of him having more than 1 accident is the same as as 1 minus P0 plus P1. Okay, so we just need to work out P1 because we already have P0 and add them together and subtract them from 1, and we're sorted. So basically we need to find out P1. So that's 10 with 1 R being 1. Again, the success is the same and just one of them, and 19 out of 20 and 9 of them. Okay, and then again when you put that into your calculator you get 0.3151. Okay, so then we're just a matter of P greater than 1 is 1 minus 0.5987 plus 0.3151. Alright, and that gives us 0.0862. Okay, if it doesn't specify an amount of decimal places, you can put them all in, but I wouldn't cut it back too much. I would put, as many as you can really. Alright, so that's that one. As I said, there can be situations where you use a combination of Bernoulli and other methods. to calculate the probability. Okay, these cases tend to be ones where the problem refers to something happening on a specific trial or after this many turns. Okay, so again, it's just a matter of looking and experiencing some of these questions to recognize the differences between each one. So we're going to look at quickly look at an example of that type. A card is drawn randomly from a standard pack, noted and replaced. This procedure is repeated over and over again until 2 spades appear. Find the probability that this will happen when the 8th card is drawn. Okay, so if it was just the first sentence, this would not be a Bernoulli trial. But the fact that they mention in the second sentence the 8th card, that should kind of get your Bernoulli triggered. Okay, your sensors or whatever. So basically what we say is, okay, something specific has to happen on the 8th card. It has to be a spade. Okay, because if 2 spades appear before that, well, then we'll never get as far as the 8th card. So up until that point, all cards, the first 7 draws, there has to be exactly 1 spade for the second one to be on the 8th draw, 8th card. That makes sense? So basically we're splitting it up. We're splitting it up into the first 7 draws, and then we have the 8th draw. Okay, so this is what I mean in terms of a combination. So the first 7 draws, the first 7 draws fit the conditions for Bernoulli. Okay, first 7 draws, we have from the first 7, we want 1 success or 1 spade. What's the probability of a spade being drawn? Probability of a spade, there's 13 cards, 13 spades out of 52, so that's 1/4. Okay, we want 1 of them, and then of all the other types of cards, 3/4 of the pack are not spades. We want 6. Okay, so we want exactly 1 spade in the first 7 draws. All right, so we work that out, and that turns out to be 0.31146 approximately. And then on the 8th draw, what do we want to happen? Okay, so this is basically P1 for this bit. The 8th draw basically is we want, what's the probability of a spade? We don't need Bernoulli. What's the probability of a spade being drawn? That's just straightforward quarter. Okay, or 0.225 or whatever you want to say. Okay, so we have these two. Both of these two things must happen together. Okay, so we want 1 spade from the first 7 draws, and on the 8th draw we want a spade. So we multiply those two together. So basically our answer is 0.31146. So basically the probability of 2 spades being drawn, the probability that 2 spades, the second spade will be drawn on the 8th card is 0.31146 multiplied by 0.25, and that gives us 0.07786656. So there are 2 different types of questions we've looked at. One where it's just a Bernoulli, making sure that you understand when to apply Bernoulli and when to basically look at another option, another strategy. And then the last example here with the cards is a special case basically where you have a combination of Bernoulli and another method where you combine the 2 answers. Okay, and it's always going to be multiplying those 2 answers because this must happen and this, so 2 separate things must happen for this to come true. Okay, so that's a kind of a summary of Bernoulli trials.